All right, so what you're doing is putting together a one-line pipe drawing, squared off corners, showing how to build the pipe. Now we're putting a table in. So as you draw this, this is probably how I would start. Is I would start with something like this. That's a table. Okay, so in this case, I grabbed some data from one of the groups and just put together a quick pipe run. So here's one flange. Here's the other flange. Listed northing, easting elevation on them. As far as the calculation or the deviation, I then calculated the run that I have to do. Okay, now this is total run. Keep in mind that the path your pipe takes is up to you. And what I mean by that is, like in the northing, it's got a -1 foot 5 7/16. Okay, the minus and plus doesn't really matter much, and it just tells direction. Okay. Now, what it matters is that this thing's going to go about 1 foot 5.5 inches approximately. Does that mean the pipe run goes 1 foot 5.5? No, not really. Because maybe I got to go around a beam, or I got to get to the other side, right? Because you got to match up the sides and come in. I might have to take my run off of one flange and run at 3 feet, and then I've got to come back 1.5 feet to where I match this. So the total run is listed here, but you may have to go past it, up and back, or something of that nature. So in essence, this tells you everything you kind of need to know on your end result. Now, what I would suggest that you do is get this nailed down and then draw just a quick diagram with these lengths on it. And in essence, that's how I did this one, right here. Okay, I just came out here and set my stuff to isometric and said, okay, well, I know I need a line, and I'm going, in the northing, I'm going, I got to set my polar, move computers. 1 sec. So I know I'm going south 1 foot 5 7/16. Okay, so I just came out to the side here and I drew a line, got on that axis, and I said this is 1 foot 5.4375. Okay. Now that's my total run in the northing direction. And then I go ahead and throw the elevation in here because that's going to be my next one. So this is 2 foot 2 and what is that? 3/16, so 0.1875. I know you guys got all those memorized, right? It's really going to pay off if you do have memorized when we go to drafting 156 here in about 3 weeks. And then I'm going to run my easting direction, which in this case is this way. Okay, and it's going positive, so that is 3 foot 36, 41, so 41.0625. So there's my total run. Now, I don't know where I didn't know on this, if this flange was on this side of an I-beam and this one was here, so I just assumed that one was here and one was faced the other way. You need to make sure you're matching up with yours. You might have to go over there and take a picture of them and say, okay, this is where they sat, but you can insert that picture now in your drawing. So in this case, I couldn't run this way and come up on a beam and have my flange coming the same way. So I, in essence, chopped this guy in half, put a half of it here, down here, and then moved the other half of it up into that zone and put it here. Okay. Whatever the case might be to get you to those. If you've got to wrap around a post or something, you can make it any real direction you want. Ultimately, if we were in industry, you would want this thing as straight line and as simple as you could get it, because it uses less materials, takes less time to build, and it performs the function. You have a wide range of options here, and I don't think Clay really cares. He wants his people to build pipe and to do it accurately, and he's not too worried about this thing saving the company's bottom line. So feel free to step outside the box. Now, if you've only got to go 2 feet and your pipe runs 19 feet, we're going to neck that down. Okay? Don't get too carried away. Okay? Now, as you come into it, Typically, what you would have is a dashed line coming off of this right here. You guys know you're just coming into a blank flange, so I showed that flange. That should be a hidden line because it's an existing. Okay. So I haven't shown that yet, so I'm just going to come in and take this guy and throw it to the hidden layer. Okay. So you figure out a scale. What worked for me on this one, I think I'm at 1.5 to a foot. Please use an architectural scale, and that'll get your text size. So that second flange is an existing one. When you make these corners, I'd like you to do a squared off corner and show the plane. Okay. So in essence, when you do that, we want 90-degree corners or 45s. I'll give you extra credit if you do 45. I'll give you another extra credit point if you do a compound corner. By that, a corner that goes 2 of the axes rotations. Follow the examples in the text because we don't draw 45-degree triangles on isometrics. We actually draw them at 22.5 degrees. You have to do trig to figure out the length of pipe. It should be dimensioned. Okay, and I can help you with that, those of you that have not been through the trig portion. You say, hey, I want to do that. Okay, well, we'll sit down and we'll go through how you get those numbers. It's also got an example in that handout I gave you. In essence, all I did is draw a line, 6 inches, square the corners. You put your hatching the same length as one of the 2 axes. Okay. So if I was turning up also, and drawing it at 22.5, I would have another one sitting right here showing that angle. And there's examples of that in the text. You can use hatching if you wish. Okay. So if I was doing this corner right here, let me show you how I throw this together. I'm just going to draw a line 6 on that axis. Draw another one this way because a 45, 45, 90 triangle, sides are equal. Let's draw the line back. And then all I did from there was draw a line here, 1 unit, and then draw that straight up. And then I'll use the copy command. So copy. And trim it up. Typically you want this to match up where it's 1, 2, 3, 4, 5, 6. And then I would put the text down here showing them that dimension. Let me delete these on my pipeline. And you end up with that setting. And it shows them the angle that they're turning because isometric angles aren't true size. You can use the ANSI 31 hatch, but it's hard to get it to match up. Then the only thing left I would do is dimension it, add my notes. Remember your north arrows pointing up and to the left. You can make your own north arrow using a P-line or a block like we did back in dimensioning or previous classes. Or you can download it out of the Design Center. In the Landscaping Design Center drawing, there's a north arrow. I just made a quick one out of a P-line. North goes top to left. Or up towards the top left, sorry. That axis.
I thought in theirs they go to the other.
What's that?
They go toward their standards and they go to,
Yeah, the standard's top right.
yeah, okay. That is their standard, right?
Yes.
Okay.
Mm-hmm. Okay.
So,
Now,
why do you have why do you do that on the corners?
just to make sure they pick up the right angle. Because they've got to get the right, and this angle is 120 degrees on this drawing. None of these angles are going to appear right. And then you throw a 45 in here, and a 45 is really a bad angle in an isometric. And so you're going to see when you do those, it recommends in the text that I gave you on piping, draw those at 22.5, and then you tell them through this triangle, you give them offsets, what the angle of the corner is. So they get the right fitting. Because if you got the standard fittings, 22 and a half, 45, and 90. We're not gonna do any 22 and a halves. You can go a 45 if you don't wanna go 90. And that will be an extra credit point for you if you do. Follow the guidelines set down in the document.
Are there any angles or any, I guess angles that don't get those hatching?
Well, some people don't even put them at all. Right, you might just put a little squared off 90-degree sign in there too, right? Some people will do that. Some won't do it at all, they'll actually dimension it. So I would put in here a dim angle and put it at 90 degrees, override the text. This is a good way, it's primarily designed for compound angles, is what this method's done for. But remember, I can turn in this one turns in one axis, right? But I kind of swing it, and also, instead of going only to the east like I do here, I can go east and elevation and shoot up like that. Yeah, I can do that too. That's primarily what this is designed for. So I do want you to use those corners so you see them. Whether you do the compound angle or not is going to be up to you.
And what exactly do you mean by compound angle?
You turn through two axes at the same time with that angle. Remember when we were over there and we held those two fittings together? And we kind of held them in one axis? Like they got to weld that thing, they can rotate it and go two axis. It's more efficient use of pipe. It gets put together quicker. Because keep in mind, if I did a compound angle here, where I took this and changed this angle to match that one, wouldn't I get rid of all of this? I'd get rid of all of it. So I'm saving my company pipe costs, which are not cheap, especially when you start using these alloys. Fitting costs, and probably the most expensive part of it all, labor costs.
Is there an increase in mistakes?
Yeah, there probably is. It's a little more complicated.
Yeah, I think so.
Yeah. Especially for people that are newbies. Just like you guys will find when you get to the workforce, you're going to make more mistakes than you will 2 years down the road. Just like I did when I went there. Made a lot of mistakes that first 6 months. Had my egg on my face a lot. But that's a good school. It teaches you not to make those mistakes again. It's okay to make a mistake once, right? If you make a mistake twice, okay, that's kind of there. If I make a mistake 3 times, I'm, in essence, not trying. That's my thought pattern on it. I love people that only make one mistake. Then they never make that mistake again. Heard that from my dad, by the way. It served me well through the years. All right, anyway, that's in essence what you'll put this together. Don't spend a huge amount of time on it. I'm not going to make this due Friday. I'll probably make it due Monday. So you got a couple days to work with it. If you're totally confused, you don't know how to make this get going, get with me. I'd be happy to sit down and run through the steps with you. Be happy to. That's what I'm here for. This project is really the first time we've done this in here. So it is going to go through some revisions on how we put it together. I haven't given you much documentation other than here's a folder and there's datum points, go to it. But try your best, we'll work through it. Future classes will benefit from your efforts. All right, any questions on this?
I have a question, but maybe it's for Friday. The plus and minuses, I mean, you can take the numbers and do them so they're all positive. I mean, I don't, you subtract the big from the little, I'm kind of confused.
Well, it just tells you
Plus or
direction.
minus.
tells you direction. So if I started at flange 7, which I did, which is this one,
So it depends on which
and
line.
I've got a difference between the two of a negative, and that's a northing, means the pipe runs starting some point and going south.
Okay, so so it depends on whichever, right? You can put the other flange up top, then you'd be going the other way.
That's correct.
Okay, so that chart, okay.
Yeah, if I would have started
Okay.
here, this number would be positive, and I'm running my pipe run
Gotcha.
north.
Okay, so depending on whatever you put in your chart, you better follow it, whichever way you put it, okay.
Yeah,
That makes
just
sense.
don't,
Okay,
don't switch them back and forth.
yeah, okay, that was my, okay. So you can go whichever.
Good
okay.
point. I
You
think,
go
I
whichever
think
way.
I'm understanding what you're saying.
Yeah. I mean, I get the number, but I can go either way. I mean,
Don't be taking this easting off of this one and put it down here and take that easting and put it up there to get yourself a positive number. Because these all go with one point in space. This is defining one point in space. This is defining another point in space. The positive negatives only tell you which direction. This is a negative, and I'm a northing, it's running south. This one's a positive and it's on an easting, it's starting west and moving east. This one's elevation is starting low, it's positive, it's going up. But yes, these could be totally reversed if I started drawing this from 21 and I had it on top. Okay.
okay.
Yes.
That answers my question.
Okay. All right, I'm just expecting something that looks a little bit like this with dimensions. Please dimension your runs. And you just throw one dimension on there, so. Do I got my steel? Yes, I do. Okay, so you're gonna do that, and then remember how to align those things in. Okay. So you're gonna use the obliquing option. Oops. And I haven't switched this to architectural, but it should be architectural. B sheet worked really well for this. If you run smaller, feel free to go to an A. Make sure you list your scale. Please use an architectural scale. All right, I'll leave that one. Ask me questions if you've got them. All right, as far as your drawing goes, yesterday we put together the body of the house. Any questions on this? You had one other requirement here, and that was that you add a garage apron. Okay, so what I want to cover today is, I'm going to try and go fairly quickly, but how do we add other items to this to enhance the pictorial drawing of this? And I'm going to do this every single day, just take a half hour and go over different items. Certainly, don't limit what you do to what I do up here. This is a piece of art. So think outside the box. I noticed one person took it off and made a sketch around it and said, oh, I'm going to put this here, this here, this here. That's a great way to go about it. I'll just go over some things that you might use here. So first off, how would I add a garage slab to this thing? Whenever you add a physical object, draw it in your two views and then project it as if it is. So if I've got a garage slab I need to add, okay, and let's see, just to make sure you know what I've got, did I leave my thing in here? I did. Let's see if give me 1 second here. No, I didn't copy it over. I'm going to go get you a picture here real quick. This ought to show me one. Okay, so here's a garage apron. So what we're talking about here is a piece of concrete, usually we call it a driveway, right here, that comes up. Typically, they're the same width as your deal. Now, they sit right on the surface of the earth, right? They're actually 4 inches thick as a general rule, because 4 inches of concrete carries a car without cracking. So the depth is down in the ground. So in essence, we're just doing a surface here because we can't see the stuff that's underneath it. Okay, so I don't have to worry about height, because the height is already defined on my structure by the bottom of the garage door. But this is what we want to draw. So go to your views. I'm not going to draw it in this view because that garage apron, the height of it is sitting right here, right? In front of my garage. I asked you in the notes to make it the same width as the house. So what I'm going to do is just draw a line on the outside of my garage wall. What layer am I on? Okay, so just draw it the same angle as your house on the outside of the walls. Now I'm going to move those lines out like such. Then I'm going to use an offset of 24 feet. Oh, I need another line because I can't offset my X-ref. So I need a line right there, offset 24 feet. And then I'll just extend and trim. So there's my garage apron in the top view, right? Now I just have to project it. I've already got most of the information for this. Now I will tell you, this goes off of your drawing in the plot sheet. Okay, so you're not going to display the whole thing, but that's okay, because wherever it chops off, it chops off. But let's go ahead and draw it in. So if I come to this drawing, I've already got the height, right? Isn't it this line and then this corner that vanishes? Isn't that the height? Okay. So I need a line that vanishes left because that's what that plane vanishes, right? This thing's on a vanishing left plane. Okay. So I'll take that, I'll just come out here, draw myself a line. And let me do the other side too so I can switch line weights. And then we'll extend out to it. And I'll trim it back now. And let's trim that one. Delete that guy, delete that guy, grips, pull this one down. All right, so there's both sides of it. Now all I have to do is locate where the end is. Now, once I locate one corner, does this side of the thing, does it vanish? Vanishes right, didn't it? Okay, so all you gotta do is locate one corner. So I'm gonna use my station point for that. So I'll come up and hit that corner. It's in front of the picture plane, so I must extend through till I hit the picture plane. Then I bring that down. I'm doing the inside corner, so it's gonna match there and then vanish right. So now I've got that drawn in. So let me trim it up. That's a pretty common thing to do, isn't it? Now folks, I want you to be cognizant of line weights. Is this a real sharp corner? Do you see it? You generally don't even see the edge because grass is growing over the top of it, right? All you see is just a plane. So make sure, play with your line weights. Now, I wouldn't use this to change line weights. I would make layers. Okay? So if I want this to be a thin line weight, I would put it at, I don't know, maybe an 004 or something of that nature. I'm going to hatch it probably a gray color. Or if I wanted it to be a blacktop one, maybe I've got a real trick house and it's brick, okay, or cobblestone, okay, whatever the case might be. I'm going to do that. Now, some other things you can do for depth. Let me just grab a visual aid here. once you've got your thing done, by the way, let me ask a question. Does anybody think they're gonna print this and go to alternate picture device like pencil, paint, crayons? Jess, you are?
If I can't get it done on this.
Okay, yeah, certainly I think learning how to get an eye-pleasing picture on the computer is a good skill to have, but I will tell you, I don't think you will ever get to the point on a computer where it matches that warm feeling that using a physical device like a pencil or something gives you. I think that's pretty standard across the board. Almost everybody would agree with that. Now, we do go renders when we do 3D solid models that are the exact duplicate. And we can make those look very, very real life. They still aren't art that make people feel good. They're fairly emotionless drawings. Okay, and keep in mind, people like their emotions touched. Except for me. Another thing you can do to create depth that works pretty well. I would do this on a bigger structure than this. I don't know that this one is worth the effort, but I'm going to point out the method so you've heard it before. Okay, I would print this guy out. Now, what happens when you look at something that's thick and then it goes off into the distance, a linear device? Does it appear as thick when it's close to you as it does when it's further away? It appears narrower. Can we create that illusion with your line work?